So in the diagram, what must be true for point D to be an orthocenter? So again, what is an orthocenter? An orthocenter, and I have D here is the orthocenter, right? If I bisect the triangle between bisect this side to this side and from top to bottom, the lines at which the point at which all three lines intersect is the orthocenter. So point D. So it says here, so which must be true for D to be orthocenter. So let me write down our solution. So A could be B, E, C, F, and A, G are angle bisectors. BE has to be perpendicular to AC. AG is perpendicular to BC, and CF is perpendicular to AB. CBE bisects AC, CF bisects AB, and AG bisects BC. And then D here states that BE is a perpendicular bisector of AC, CF is a perpendicular bisector of AB, and AG is a perpendicular bisector of BC. So basically, it's the same thing as D. It's the same as C, but perpendicular bisector. Okay. So how would I solve this problem? What must be true for D to be orthocenter? So again, take a moment to think about this problem here, and maybe think of the word orthocenter. So what does that mean when we talk about the orthocenter of a triangle? So let me redraw this. Let me redraw the triangle here, and I'll show you what I mean by orthocenter. Recall the definition of orthocenter. So again, an orthocenter, if I have a triangle like this, is from this side, I have to take the center. So let's look at this side first in blue. So let's look at this first side on this side here. I have to take the center, and what that center point does is I'm going to have to make a 90-degree line like so. So this here has to be a 90-degree line for it to bisect my triangle. Same thing with the opposite side on this side. I would have to take another line here, and this here has to bisect it in a right angle, and then from here to here has to be a right angle as well. So they all have to be a perpendicular. They all have to be perpendicular for us to construct an orthocenter, right? Because again, what you have to do is you have to actually extend. What you can do is you can extend these lines to make sure that this here is the orthocenter. Right? You can extend this to be a dashed line. This here can be a dashed line as well. This here can be a dashed line as well. So these all these lines have to be right angles of each other. Again, I drew my diagram I drew my triangle incorrectly here, but all of them have to be perpendicular to each other. So which means that A and C are incorrect answers, right? A and C are angle bisectors. Bisectors don't have to necessarily be a right angle, right? So this here, A and C are wrong answers in this case. And then we have B and D left. B says that BE has to be perpendicular to AC. And then here's BE says it's a perpendicular bisector of AC, right? So when we talk about what's the difference between perpendicular and perpendicular bisector, so it says here, let me look at perpendicular first, right? So if I say something is perpendicular to each other, that means that I'm going to do this in red. That means that BE is this line here. So this here is BE has to be perpendicular to AC, right? So this here, these two lines have to also be perpendicular to each other, right? When we talk about a perpendicular a line here. So in this case, because BE is already because it says here B, it's confusing with the wording because this BE is a perpendicular bisector of AC, and that's actually not correct, because what that means is if BE is a perpendicular bisector of AC, that doesn't make sense, right? I have AC here is just this line, right? From A to C is, oh, this is not, this is, sorry, this here is a G. Sorry, this here is G. So it's A, oh, sorry, AC is this line. Yeah, AC is this line here. So it's actually not, sorry, I wrote the wrong line. So it's actually this line here. So this has to also be a right angle here, right? Oh, sorry. I think I erased that. So this here is BC and AC. This here is also a right angle. But BE in itself is not a perpendicular bisector of AC, right? It's a perpendicular bisector of the triangle itself, so of ABC, right? So in this case, BE is a perpendicular bisector of ABC, CF is a perpendicular of ABC, and AG is a perpendicular of BC. So this here is actually tricky on the wording. So in this case, D is actually an incorrect answer, and B here is our correct answer here. So like they said, option B here is true, right? So why do we know B is the correct answer? Because BE is perpendicular to AC, right? As we showed from the orthocenter, this here, or I guess this is here, this orthocenter, but BE in this case, BE here is perpendicular to AC, right? So this here is a right angle here, and that's correct, right? For point D to be orthocenter, that's a definition of that. But BE is not a perpendicular bisector of AC. AC, you can't really bisect AC, right? Like AC is simply just the line. I can bisect this. Bisecting this is not, it's not a perpendicular bisector, right? A perpendicular bisector of the triangle is BE. So this here is just a case of the wording here. So again, here it says that for the point D to be orthocenter, the only necessary part is BE is perpendicular to AC. They don't necessarily have to be bisectors of the side. So that, like I said, AC is not it's not like a bisector of ABC. So B here is the correct answer. So I'm going to say good solution and logic, because this solution here is correct.